actually going to get started because I have 50 minutes and I have 55 new features to get through. So I did this presentation Monday in Riga at the Dev Days, and 55 new features in 50 minutes is definitely kind of pushing it. So we will keep moving. Obviously, JDK 9 is scheduled for release at the end of July. July is shaping up to be a very exciting month because not only is it the release of JDK 9, it's also the return of Game of Thrones. So I'm very much looking forward to July. Anyway, let's move on because I want to get through as many of these as I can. Now, what I've done is I've divided this up into a number of areas to talk about different sets of features because there are a lot of different things that we can go through. So the first one I'm going to talk about is major features. And clearly the biggest of those is the Java Platform Module System, JSR 376. Now, I'm not going to spend too much time talking about this because there are many other features that I actually want to go through, and there have been a lot of presentations on Jigsaw and the platform module system in the past. But one thing I do need to say is that last week there were some developments in terms of the JCP and the JSR for Jigsaw, JSR 376. Now this went to what's called a public review ballot, and the JCP Executive Committee, of which Azul, the company I work for, are a member, voted against the public review of Jigsaw. Now, do not be alarmed by this. It is not the end of Jigsaw. It does not mean that modularity is not coming to Java 9, because it's been coming for quite a while now, because it was in Java 7, then it got moved to Java 8, now it's been moved to Java 9. It is not going away. All that has happened is that the JCP Executive Committee felt that a bit more time was needed to work on the specification. There were some issues around getting agreement in the expert group, getting some of the issues that still are outstanding in terms of the functionality of the platform system, how it interacts with other module systems, and so on. So all that's happened is it means that the expert group and the spec lead of that, who's Mark Reinhold, have another month to do some more work and then resubmit the specification. I believe that when the specification comes up for review again, it will pass. We'll have to wait and see if that happens, but I think that it probably will. I was at the executive committee meeting in Austin last week where a lot of this was discussed. So what is modularity in Jigsaw? Like I said, I won't spend too long on this because there are many other things to talk about, but Jigsaw is big. What it means is that rather than having a single rt.jar file with all of the classes that are available in the class libraries for Java, you now have a number of modules. Now, back in the old days, version 1.0 of the JDK, there were about 200 classes, so that was quite manageable. In JDK 8, 4,500 classes in the standard class libraries. That's now been broken up into 94 modules. So if you look in the mods directory of the JDK in JDK 9, you will find 94 modules. One of the big things is the encapsulation of the private APIs. Most famous of these, or infamous of these, is Sun, Misc, Unsafe. There's also a lot of changes around the way reflection works in terms of being able to access classes and objects through the Java language. And so this encapsulation means that things that you may have used in the past, which are private APIs, non-public ones, will change. If you have done that, there are various ways that you can get around those issues from a compatibility point of view. There are two command line options, ---- add exports and ---- add opens, which allow you to say, I need these modules to be either open for reflection or exported so that I can use the things in there. Now, the other thing is that the source code itself has been modularized. This is not actually part of the module system. It's the way that the build system works and the way that the code is actually organized in the source code tree. One of the things with Jigsaw, as I say, is compatibility. If you have used only the public APIs that have always been available, you will not see any issues. Well, perhaps a very, very small number of people might, and I'll come back to that later on. But on the whole, if you just use the standard public libraries, you will not have a problem. If you've used weird ways of doing reflection, if you've used the non-public APIs like SunMist GunSafe, then there could be some issues. More recently, there was another command line option that was added to the platform module system, which is -- permit illegal access. So you get back all of the things you had in terms of encapsulation and the reflection. So that's another good way of being able to get backwards compatibility. One of the things you can also do is you can simply leave everything on the class path. You don't have to move to the module path. So leave everything on the class path, put on -- permit illegal access, and everything should run exactly as it did before. Jlink is another thing that's related to the idea of the Jigsaw project, where the fact that we now have a module system means that we can build a runtime which doesn't need to have all of the APIs that are part of the standard Java platform. If you want to build like a microservice or an embedded system where you just want a runtime that contains the bits you need, then you can use Jlink to do that. Jlink takes a number of command line options and allows you to build a runtime image as a file system which contains only the modules you need, and that's the platform modules and the modules for your particular application. What you get is a directory structure which contains a bin, which has Java in it, contains a conf directory, a lib directory, a mods directory, and so on. If you do something very simple, like you create a linking version which has only one module in it, which is java.base, then when you run -- list modules, you will see only one module. Interestingly, one of the kind of issues that we brought up to the JCP was, if you don't have all of the modules for the Java platform, is it still considered Java? Because of the write once, run anywhere, everything has to be, the same for everything. And the answer is yes. So as long as you have a runtime which is designed for your application, and it only contains the modules that it needs, it is still considered to be Java, even if it doesn't have all of the modules that are part of the core JDK. If we look at a slightly more advanced example where we take an application and we build a runtime for that, what it will do is it will trace the dependencies of all the modules that it needs for that application, assuming that you've used modules rather than leaving everything on the class path. If we now do -- list modules, we'll see that we've got Java base, we've got Java logging, SQL, XML, and then we've got our app and a couple of modules that it depends on called Zoop and Zeta. The observant amongst you will notice that there's also some numbering there, and you might be getting excited. You might be thinking to yourself, oh look, we've got versioning. No, do not get excited. Versioning is not part of Jigsaw, and in fact I put a quote here from the state of the module system, which is kind of like where the specification came from, and it says, it is not a goal of the module system to solve the version selection problem. This has been something that's a bone of contention with a number of people in the expert group, but the reality is that for JDK 9 there will be no versioning of modules in the platform. This information, although it's included, doesn't actually make any difference from the point of view of resolving dependencies. Moving on from that, what other things do we have? Well, first thing is that collections now have some nice factory methods. And if we look at things like set, list, and map, which are the interfaces almost at the top level of collections, if we want to create a collection with a default set of values, and we want to make it structurally immutable, meaning that we don't want to be able to change the references within that, we don't want to be able to add any objects to it, we don't want to be able to remove any objects from it, then it requires quite a lot of code. So if we look at an example, simple example, creating a set, create a new hash set, we add 3 elements to that, and then we need to make it immutable, so we need to call the unmodifiable set method on that. So what we're doing here is 5 lines of code to add 3 elements. In the collections API, in JDK 9, we now have 12 new methods in each of the interfaces list, set, and map. Why 12, you ask? Well, it's kind of a bit weird because there are 11 methods which are overloaded to give you the ability to add 0, 1, 2, 3, all the way up to 10 elements to a collection. And then there's also one more method overloaded, which allows you to add an arbitrary number of elements using the var_args constructor. So we get a lot of these new methods. They're all included in the interface. And the reason they can do that is because of the change in JDK 8, which allowed the inclusion of static methods in interfaces. So in Java, we now have the idea of multiple inheritance of behavior as well as multiple inheritance of state. Still don't have multiple inheritance of values or state. Sorry, no, we have multiple inheritance of types, not multiple inheritance of state. So that's the important thing. But anyway, that was what allowed us to do this. And so now if we look at the same piece of code, very much simpler, we simply say string set, set of strings, set of ABC. And that way it becomes a much simpler piece of code. Stream enhancements. Streams obviously was one of the big things in JDK 8, and that's proved to be very successful, and there are a few things that are being added in JDK 9 to make it even more useful. First of those are two methods called drop while and take while. Now, these are similar in the way that they work to the skip and the limit methods that you already have. Skip and limit allow you to say, I want to skip the first n elements of the input stream and then return the rest as the output stream. Limit says take the first n elements of the input stream and then stop taking the rest of the stream. So these work quite nicely, but you're restricted in the sense that you have to provide a value. Drop while and take while do the same thing, but rather than taking an explicit numeric value, they take a predicate. So in essence, an if statement. So a condition that needs to be satisfied in order to change whether elements are either dropped or taken from the stream. So you can specify your predicate, and then you can say, okay, if this particular situation is valid, then I will either stop taking elements or I will start taking elements from this stream. One thing to note about this is that you can have some unexpected effects if you use an unordered stream, because the predicate only needs to be satisfied once. If you have an unordered stream, and let's say you're saying take elements until the number from that stream is less than 3, you get a number less than 3, and you stop taking elements. But there could be other elements further down the stream which would still be valid for that particular take while. So it's just something to be aware of if you use that an unordered stream may give you inconsistent results. The iterate method has been improved slightly. So in JDK 8, there was an iterate method that took one argument. Now there's one that takes 3 arguments, so you can make iterate look very much like a traditional for loop. So you have the idea of your initialization of value, you have the ability to repeat until a particular situation is satisfied, and then you also have something which executes every time around the loop. These are done through functional interfaces, so you can use Lambda expressions to represent how you want to do that. You can make it look very much like a for loop. Files.lines allows you to read a file, strings from a file, in parallel. This is very useful because if you were to try and use a parallel stream to process a file using like buffered reader at the moment, the problem you would have is that you would actually get very, very bad performance. It would actually be worse than using a sequential stream. The reason for that is obviously that by reading a file, you're reading it sequentially, each line at a time. So trying to divide that up into parallel threads doesn't work. With files.lines, what happens is the entire file is mapped into memory. That area of memory can then be divided up based on line breaks, and it's divided up ideally in chunks which are equal, but because the line breaks may not occur exactly on a boundary, it will do its best to divide it up into equal-sized chunks. And then separate threads can take lines from those individual memory map chunks and do it independently. So you can get much better performance in terms of file.lines. Optional also has a couple of new methods in it. One of those is the ability to create a stream from an optional. So a stream of 0 or 1 element. If the optional contains a null reference, you get 0. If it contains a valid reference, you get a stream of 1 element. You can then pass that stream to all the other stream type processing things and do interesting things with it. Multi-release jar files. The idea behind this is that jar files are being extended to enable you to have different versions of code depending on which version of the JDK you're using. Now, I know I said in Jigsaw there's no versioning. Well, that's quite true. But obviously the JDK still has a version number associated with it. And what you can do now is create a jar file that can support more than one version of the JDK. Now, there's a bit of a sort of limitation on this because obviously we're starting with JDK 9, so we can support JDK 9. Then we'll be able to support multi-release for JDK 9 and JDK 10 and JDK 11 subsequently. Actually, that's a bit unfair because you can put a version of JDK 8 in there and a version for JDK 9. As long as you put the JDK 8 version at the top level in the jar file, then a non-multi-release jar file compatible system will simply read whatever's at the top level. It's only if you use JDK 9 or later that it will read versions subsequent or further down in the tree structure. So it does actually work for JDK 8 and JDK 9, or JDK 7 and JDK 9, but not JDK 7, 8, and 9. Various things have had to be changed to support that, things like the class loader, jar file form API, the tools you would expect like Java C, Java P, and so on. JShell, the REPL, the read, eval, print loop. This is another fairly major feature that we have in JDK 9. What this allows you to do is simple prototyping. You know, many languages already have this, so it's not exactly sort of a new groundbreaking feature. And what it allows you to do is say, okay, I need to test this little bit of code. I need to understand how this particular API, these particular language features work. So I'll do it in the REPL rather than having to fire up my IDE, create a class, create some unit tests to understand what's actually going on and test things. So it is actually quite useful. I must admit, when I first saw this, I thought to myself, oh yeah, I won't be using that much. And I've subsequently found that there are definitely situations where I think, I wonder what would happen in that case in my code. And I just fire up the JShell and then type in a few lines of code and go, oh, okay, that's how it works. So then write the code in my IDE. The other reason for doing this was really to try and address some of the weight, if you like, which is associated with learning Java. So some universities are not using Java as the primary teaching language because of the fact you need to create classes, you need to create methods, which is all very good, but it kind of takes away from the act of learning about how the language itself works. Concurrency updates. So the concurrency utilities were introduced back in JRE 5, and there have been various updates to those. There are a few new features added in JDK 6. JDK 7 introduced the fork join framework. JDK 8 added parallel streams to simplify how we can have cooperating threads. What JDK 9 does is add, again, some more features. There's really two areas that falls into. The first is the idea of having reactive streams. So this is where we want to have something where we need to process things asynchronously. That's become very popular, especially with sort of web applications and microservices and things like that, where we want to be able to call a service remotely and simply be able to call it without worrying about load and things like that. So reactive streams and the Flow API that's been introduced in JDK 9 introduces the idea of having a publisher and a subscriber framework associated with concurrent applications. And that way what you can do is you can say, okay, I've got my client, which is going to request things from my server, and the client is going to act as a publisher. So it kind of seems a little bit the wrong way around, but the client actually acts as a publisher saying these are the requests. So the requests are what it's publishing. The server acts as the subscriber, and so the subscriber will subscribe to the publisher saying, I can process this many requests before I need to stop. So rather than having to block or buffer or whatever. So it says I can process, let's say, 5 requests before I need to do some, stop processing those requests. That way the client knows how many requests it can make of that particular server before it needs to think, do I then go to another instance of the server, or do I wait for that server to tell me it can do more? Things like that. So it's a simple way of being able to handle asynchronous processing where you don't want to necessarily keep polling to see can that server deal with another request. So there's a whole set of classes around that. The flow is the main one. There's a publisher, subscriber, processor, which is both a publisher and a subscriber, so you can chain them together. And a subscription is what links the different things together. And a subscription defines how many things can be processed by the subscriber. The other big thing around concurrency updates is the completable future. And completable future was introduced in JDK 8 as an alternative to a standard future. And the idea with a future, obviously, is that you're executing something asynchronously, but you have to wait for the response to be processed and a result to be generated. Sometimes, by using the get method on a future, you actually end up blocking, even though you're trying to do it asynchronously. So the completable future was a way of getting around that problem. It also made life a lot simpler from the point of view of not having to create executors to do some of the work. So it was all kind of hidden underneath. So there's various things that the completable future now has that it didn't have before. So there's things like the ability to handle delays, the ability to handle timeouts, so that if you're waiting for something and a certain timeout is reached, then it will return a result rather than continuing to wait because it may be waiting indefinitely. There's also better support of subclassing because typically people will subclass the completable future in the code that they're writing. And there are a few new static utility methods. There's one called minimal completion stage, failed stage, which is still not 100% sure I understand about failed stage. And then there's two which I really like the name of, which is a new incomplete future and a failed future. So you can have your future fail. Deprecation. Right, deprecation's been around for a long time, since JDK 1.1, and the deprecated Javadoc tag was introduced. JRE 5, we had the annotations introduced, so we got a new annotation called deprecated. Problem with deprecation, as it has been up until now, is it's tried to be used in too many situations, and it hasn't been clear enough about what it really means, because there are situations where APIs need to be deprecated where they really need to be removed because they just don't work in the way that they should do. But there are also situations where things could be deprecated, but they're not that bad, so we'll leave them in the API, but we'll encourage people to use a different version because that's a better thing to use, may have better performance or whatever. So the idea with the deprecated annotation now in JDK 9 is it has two new methods. The first is a Boolean, which is for removal. And that really indicates, will this particular element ever be removed? So if it returns true, then the idea is that it will be removed potentially in the next release. And in fact, for removal, when it says it's true, the idea is it will be removed in the next release. If it returns false, then it won't be removed until at least after the next release. There's also another method called since, which returns a string, which tells you which version of the JDK this particular element was deprecated in. So it gives you more information about that if you're interested in that kind of thing. There have been a number of deprecated tags added, and there are even 2 deprecated tags removed. So things have been, we had a discussion about this. Does it mean that they were precated, or were they de-deprecated, or undeprecated? But I guess, anyway, they had the deprecated tag removed. And then there's a nice little utility that you can run, same as JDeps, which does JDepra scan, and will look at a jar file and tell you where there are deprecated elements that are being used within that. Project Coin. Project Coin was JDK 7, and this was a number of small changes to the Java language. So it introduced things like strings in the switch statement, the try with resources way of doing things, various little things like that. And JDK 9 is adding a few more things like that. So the first of those is that a single underscore is no longer going to be valid as an identifier. So hands up anybody who's used a single underscore as a variable name. That's good, I like to see that. Well, if you really are dedicated to the idea of using just an underscore as a variable name, you can use 2 underscores, or 3 underscores. I actually checked to see whether this would work, and it does. But the idea of using a single underscore is not going to be valid anymore. And there is a reason for that, because in JDK 10, the idea is that it will be valid to use that as an identifier for a lambda expression. So if you have a lambda expression which takes a single argument, doesn't use the argument in the body of the lambda expression, you can use a single underscore to kind of hide the fact that there's a variable there. Private methods in interfaces, because, as I said, multiple inheritance of behavior was introduced in JDK 8, the idea of default methods in interfaces, the idea of static methods in interfaces, it now makes sense to also have private methods in interfaces, so that you can take common code from your static methods or your default methods, and you can shift it into a single private method which can't be accessed outside of the interface. Effectively final variables in try with resources. One of the problems with try with resources is that every variable you reference has to be assigned to a new variable instance when you create that try block. Even if you have a reference to that variable outside of the try block, you have to assign it to a new instance of a variable when you create the try block. In JDK 9, if that variable is final or effectively final, meaning it behaves in the same way as if it was marked final, then you don't have to assign it to a new variable in your try with resources block. So again, it's just simplifying a little bit of code there. Safe varargs on private instance methods. If you look at the way that safe varargs annotation has been used up until now, you can use it on things like constructors, you can use it on final methods and static methods, with the idea that none of those can be overridden. Well, constructors can, but not in the sense of using safe varargs. Because private methods can't be overridden in a class, then it makes sense to include those in the way that safe varargs can be used. Also, diamond operator with anonymous classes. Again, this was something that was considered in JDK 8, but they decided against it. The reason for this is that when you use an anonymous class and you assign that anonymous class to a generic type with a type parameter specified, the compiler can infer the type, but there are situations where you can get a type which is inferred by the compiler, which the compiler understands, but the class file format that is used by the JVM, it can't be expressed in that format. So there's some odd situations where that happens. So now if you have a situation where the compiler can infer the correct type and represent it in the JVM class file format, then you can use the diamond operator with anonymous classes. Standards. There are many standards which need to be updated for JDK each time it's released. Relevant standards. So the first of these is Unicode. Unicode. So there have actually been two major releases of Unicode since JDK 8. Unicode 7 and Unicode 8. In Unicode 7, they found 2,834 new characters to include in the code set. In JDK 8, they found 7,716 characters that they hadn't found before. Anybody want to guess where most of those characters came from? Emojis. But funnily enough, in JDK 8, because I did some research on this, JDK 8 also includes lowercase Cherokee. The Native American language now has lowercase Cherokee. They had uppercase Cherokee before, so you could always shout in Cherokee, but you couldn't have lowercase Cherokee. So that's now available. A couple of other things around like public key cryptography stores. So those have been updated, moving away from the Java key store to the public key cryptography standard 12. The Java docs now use HTML5, so we have slightly nicer looking Java docs. And the SHA-3 hash algorithm has been updated, trying to keep us ahead of the hackers. A few smaller features. So now property files can use UTF-8 encoding. The great thing about this, it means you can use Unicode. So that means you can use emojis or lowercase Cherokee in your property files. Another thing is the DRBG-based secure random implementation has been implemented. DRBG apparently is deterministic random bit generator. I'm not quite sure how you can have a deterministic random number, but apparently you can. So that's now improved. Also, the XML catalog API has been updated to the most recent version of the Oasis XML catalog standard, version 1.1. This is what you use with JAX-P in certain situations. Inside the JVM, there are many changes. Now, the first of those is quite big because the default garbage collector is now G1, or garbage first. Reason for this is that in the past, you have had, by default, on a server class machine, the parallel collector. And when I say a server class machine, that is a machine which has 2 or more processors or cores, 2 or more gigabytes of memory, and is not running Windows. And that is classed as a server machine, and by default will have the parallel collector. Now it uses G1. Parallel collector was more about throughput. G1 is more about the idea of low latency. However, there are some things which, in terms of G1, I'm going to use a slight marketing slide here. In terms of G1, it still is a stop-the-world collector. It still has a fallback to a full compacting collection of the old generation if it can't keep up. All of the GCs that you will find in commercial JVMs, except for one called Zing, which is from Azul, who I work for, we have a truly pauseless garbage collector. So if latency is an issue for you, have a look at Zing. End of advert. Better string performance. This is internally in the JVM again, so one of the things is looking at compact strings. Now, this is not about trying to compact them by using a compression algorithm like zip or something like that. It's just about how strings are represented internally in the JVM. So it's about, again, improving performance. Also, how strings are interned, so how they're dealt with internally, has come up in terms of the way that the character array objects are used, and how they can actually be shared between JVMs. So rather than having multiple instances of the same string, you can actually share them amongst JVMs and improve the way that your memory is used. This can be quite important if you've got very string-intensive JVMs that have, you've got multiple instances running on the same machine. String concatenation also came up for some performance improvements, and the way that this works is by using the invoke dynamic bytecode that was introduced back in JDK 7. What this really does is shift the way the implementation of how string concatenation works from the compiled code that's generated by the Java compiler to letting the JVM decide what makes the most sense. This has been used in a number of places to improve performance, not just string concatenation. But it allows the JVM to then say, oh, okay, how can I use different things internally? So if there's hardware acceleration it can use, then it will get better performance. Also, on the aspect of performance, this is a lovely graph, this is. If you're using graphics with Java, then there are different graphics rendering engines that are used. By default, in OpenJDK, there is a graphics rendering engine called Pisces. It is open source, so it is fully released under an open source license. The performance of that, which is the green line, sort of green mush at the top, is not as good. So higher up means worse performance. This is latency we're looking at here. So Oracle, in their JVM, replaced the the Pisces graphics rendering engine with a commercial one called Ductus, which has better performance. And that's the, what is it like? It's the red one at the bottom. This has now been replaced with another open source version which gives you pretty much the same performance. So the red and the blue both have much lower latency. So it's just, you get better latency now with the open source version from OpenJDK. A few smaller features. These really are getting small. Improved contended locking, so the way that the JVM uses some of the cache lines in terms of alignment and so on to improve performance of how locking works in certain situations. Also, the JVM can now take advantage of hardware acceleration for some of the cryptography that it needs to do, because a lot of modern processors have built into the silicon the ability to do encryption and decryption. So if you look at things like the G-hash and the RSA performance measurements, you get somewhere in a 34 to 150 times better performance by doing that. Also, JavaFX, for anybody who's using it, the GStreamer way of rendering media, so playing back video, that's been replaced with a new version, better security, better stability, better performance. couple of other smaller features, the segmented code cache, which as a Java developer, you won't actually see any change from a programming point of view. But again, it's about improving the way that the JVM works and getting better performance for your application. So now the way they've done that is by separating non-method, profiled, and non-profiled code. A little bit more interesting is the idea of having a unified JVM logging framework. So what they're doing now is logging all the messages in a standard way, and related to that is GC logging, because obviously we like to see what's happening with GC. So the GC logging is now using the standard unified way of doing things in the JVM. A few specialized things which are changing in JDK 9. First of these is spin weight hints. So this is a very small change. It is one method that is being added to the JDK. We're very proud of this at Azure because we proposed this, so we rock. It's also quite special because JEPs have been proposed by mostly Oracle, in fact, almost exclusively Oracle. We are the first company outside of Oracle to get a JEP accepted and included into the Open JDK and JVM product. That was no small feat, I have to say. Even one method was really difficult to go through all the process of getting it past some of the Oracle engineering folks. But that's good, because let's face it, if you're going to change the thread class, which is what we were doing, then you do want people to look at it quite closely, because obviously there's potential there for problems. So this new method called onSpinWait is designed for situations where you're looking at very low latency programming. And if you think that your particular piece of code is going to go into a processor spin lock, where it's spinning, waiting for a lock to be acquired before actually releasing the code that's running on the processor, then you can say on spin wait, and there are certain things that can happen on certain hardware architectures where you can actually improve the performance by, in effect, doing a pause rather than a spin. And by doing a pause, you actually get less power consumption and also better performance in terms of the way that the processor works. What we found with this is that if you're using the disruptor pattern or disruptor API from LMAX, we actually see quite a lot of improvement in performance there. Variable handles. As I said, things like sunmisc unsafe are being encapsulated. Yes, you can still turn on the magic command line options and get back to them, but the idea is they are going away. And what the JDK developers want to do is to replace the important bits of that with public APIs, so people can still get the same functionality, but through a public, well-documented, well-supported API. Variable handles is part of this. What it does is give you access to parts of sunmisc unsafe, which people use typically to get better performance when they want operations on variables to happen in a specific way. And that means either having atomic operations where you want to do something like a compare and set or a compare and exchange, or where you want to fence memory-specific operations, and you want to say, when I fence this particular set of operations, I don't want the compiler or the JVM reordering things in order to improve performance, which is what often happens with the way that the compilers work. Now, this kind of functionality has been around for a while, at least the idea of compare and set atomic operations through the atomic class, which was introduced as part of the concurrency utilities. The problem is, in order to do that, you have to create a new class, and it's a lot of overhead. So by doing it using sunmisc unsafe, you're kind of going down to the processor instruction level almost. And now what variable handles does is give you a way of doing that through a public API. Enhanced method handles. Method handles were introduced in JDK 7 as part of the invoke dynamic way of doing things. This is something which unless you're actually implementing a JVM language using bytecodes on top of the JVM, which is different to Java, you probably won't actually use these. These are designed to, again, help with improving efficiency of the way that method handles work. And so there are some primitives that allow you to do loops within your code and try finally blocks in a simplified way. So this is about when you're writing a compiler and you need to generate the necessary code in terms of the way your different bits work. Also in terms of the way argument handling is dealt with, so there's what's called spreading, where you take an array of arguments and you spread them into individual arguments. The reverse of that, which is where you take a set of individual arguments and collect them into an array, and folding, which is where you do sort of half and half. Yeah. A couple of smaller features related to this. There's some interesting things. Compiler control is a nice one. Now, this is not the Java C compiler. This is the compiler that's used internally in the JVM to compile your bytecodes into native instructions. So there are two of those. There's C1 and C2, often referred to as the client and the server compiler. And what you can now do is you can provide a directive file to tell the compiler about certain things you want it to do, how you want it to process things, and so on. And you can actually change some of these things at runtime through the J command. There are some changes to the process API. This allows you to get, it gives you the ability to reference information about native processes running on your machine. So now there's a new thing called a process handle, which relates to a process. It gives you information about which user started the process, what command line arguments were used when the process started up, what the process ID is, how long it's been running. There's various things like that that you couldn't get access to before. You can also kill off processes and process trees through this, obviously dependent on the security manager, so you can't just pick on a process and go, yeah, I'm going to kill that. No, that doesn't quite work unless you have permission to do it. Housekeeping. Again, a few changes here. New version string format. This is quite a nice idea, because the version string in Java has always been, well, certainly since, let's say, JDK 1.2, has always been rather confusing, because it was where, let's say, marketing met engineering. And we ended up with two different ways of referring to the version of Java. So you can see that we have like JDK 8, update 121. But if you look down a little bit lower, you'll find that's actually referred to as JDK 1.8.0 underscore U121. Okay, and then there's also issues around patches, because there was a new update numbering scheme that was introduced after Oracle acquired Sun. So now you have things like JDK 7 update 55 and JDK 7 update 60. Which would you expect to have more patches in it? Well, logically 60. Wrong, it's 55. So now we have a new way of referring to version numbers in the JDK. So you now have the major number, the minor number, a security number, and a patch number. And that way things become much easier to understand, both as humans and if you're doing some kind of processing with your code. So it's much more around the idea of semantic versioning. The file structure of the JDK has changed. What we used to see is, pre-JDK 9, you would have the JDK directory, which would have a bin directory containing the Java executable. There was a lib directory, which had tools.jar. There was a JRE directory, which had a bin directory, which had Java in it. So you had two copies of Java. And then you had a lib directory, which had rt.jar. That's changed. So now flat directory structure, you have a bin directory, which has one copy of Java. You have a conf directory, which contains any files which you might potentially need to change for configuration. There is a lib directory, which contains native code. There's also a mods directory, which contains what used to be rt.jar and is now a set of jmod files. Smaller features, searchable API documentation. This is my favorite feature of JDK 9. The fact that I don't have to scroll all the way down to like string or string buffer. No, I can just type it into the search bar and boom, there it is. It's only taken, what, 22 years. Annotations pipeline, you can now have repeating annotations of the same type. This is quite useful in certain situations, and Java-C has been redesigned in terms of how that annotation pipeline works. From Nashorn perspective, there is a new parser API if you're doing things with JavaScript through the Nashorn engine. Somebody asked me this the other day, and I didn't quite know the answer, so I put it on my slide. Nashorn implements ECMAScript 5.1, for those of you who use ECMAScript. I don't. General cleanup. Disable SHA1 certificates, mostly. There's a couple of situations where people still need to refer to them, so they will still be accepted. The applet API has finally been deprecated. Anybody still using applets? No. See, so sadly, Tumbling Duke is no more. Removed from JDK 9, 6 APIs have been removed. So these are going back to deprecated. Now, up until now, nothing has ever been removed from Java. We've just added more things to it. Finally, there are 6 methods which are being removed from JDK 9. Add and remove action listener for Pack 200 and log manager. And you have to look at that and go, well, hang on. What did they do that was so bad that means they get removed and everything else gets left behind? And the answer is that in order to modularize the JDK, there were some really nasty links that had been made between different parts of the system. And removing these allowed them to separate out the modules in a cleaner way. The JRE version selection command line option is no longer valid. So you can't do JRE -version : release to say which particular version you want to use. Again, somebody asked me this question the other day, and I had to make sure I make this clear. -version still works without the : release number. So you can still find out what version of the JRE you're using. Bunch of demos and samples have been removed, out of date, unmaintained, so just take them away. A couple of other things that have been removed related to sort of management and profiling and so. 5 minutes, good. One is the HProf agent that relates to the JVM tuning interface. This was only ever intended as a demo. Useful features now in other tools like JMap. And the JHAT tool has been removed. Again, this was an experimental tool added in JDK 6, never supported, never really designed to kind of have a long lifestyle, but finally being removed. There are a number of garbage collection options that are being removed from JDK 9. These were highlighted in JDK 8, so they were deprecated. If you were using them in JDK 8, you would have got a warning message. So there's things like if you're using parallel new collector and a serial old collector, stop it because that's silly. There's a bunch of options which are related to incremental concurrent mark sweep because that's kind of gone away, and some other things around concurrent mark sweep. And in fact, JDK 9 is deprecating concurrent mark sweep. Concurrent mark sweep, well, according to what's being planned, will go away in JDK 10. Something to be aware of. One last thing I want to mention is Incubator Modules. And this kind of comes back to what I said earlier about Project Jigsaw. Because these things were proposed a while back and people wrote a lot of stuff about it and wondering quite how this works. The idea behind an incubator module is to allow people to get access to a new API in Java, but without it being part of the standard. Because the problem is that when a new API is designed, obviously you've got a group of people who design the API, but it's not guaranteed that they're going to get it right. Smart as they might be, they might still not make the API the way that everybody in this room wants to use it. So incubator modules are about saying, okay, let's push out a new piece of functionality that we want to include in Java, but have it done in such a way that it's not part of the Java SE standard. That way people can try it out, they can give feedback, and they can say, right, we'd like it to work this way, or we think this bit works well, that kind of thing. Once all that feedback has been used and the rough edges have been taken off it, then that incubator module can be moved into the standard API and it can become part of the standard. So this is one of the advantages of having a modular JDK, is you can do this kind of thing. There is only one incubator module at the moment, which is the HTTP2 module, JEP 110. There have been some concerns about fragmentation. So if you start using an incubator module and you depend on it in your code and then it changes, what happens? Well, the same as if you're depending on any other library that you're using and it changes, you have to make some changes in your code. There's also some command line options and the way that the module system works that can help with trying to avoid those sort of problems. But ultimately, it's designed to allow the API to develop and evolve outside of the specification, so you get it right before you move it into the specification and then have real problems trying to change it later on. Just to summarize, JDK 9, big new feature is obviously modularity, Project Jigsaw, a lot of different areas, a lot of issues around backwards compatibility and how things work in that respect, modules, jlink, and so on. Number of smaller developer features that are going to be very useful. Things like the APIs for streams, reactive API, the JShell, things like that. Lots of performance enhancements. If you're not already testing with JDK 9, do, because you need to know whether your application is going to run on there. And then my last shameless marketing slide. As Azul, we produce a binary distribution of the JDK. So it's free. It's just we take OpenJDK, we build it, we test it with the TCK to guarantee that it is actually Java, and then we make it available to you for free. If you would like to pay us for support, we will very happily talk to you about that. We also support older versions, so we support JDK 6, 7, 8, and early access of 9. We take bug fixes that we get for JDK 8, we backport them into 7 and 6, and then we upstream those fixes back into the OpenJDK projects. So we are very good open source people. We push all the source code changes we make to the source code projects. And since I'm just about out of time, I have included, I created a little survey. So if anybody's interested in just giving, there's only 6 questions just to find out whether my presentation actually worked or not. So if you want to take the time just to answer those 6 questions, you can just go to bit.ly/AzulJDK9, and that will take you to my survey. Like I say, there's only 6 questions. And then of that, I maybe have time for a couple of questions. I don't know. Do I have time for questions? Yes. 1 question. Let's make it a good one. Anybody got a question? I see it. Oh, no. Okay. Well, thank you very much.